Okay, in your packet, I presented as example number 8 what was in fact number 7. So let's just go ahead and call this what it is. This is number 7, but we'll just go ahead and do it instead of switching things up. So we are to determine the exponential function that satisfies the described conditions. Okay. Well, remember, if you see a percent increase, which as is described here, which is the 17,000 per year, you know that you're going to be using the initial formula you were given for population with a constant percent increase, which is p sub 0 times 1 plus r to the t power. And each of these terms each of these variables represents a specific thing, and our first specific thing we want to substitute is p sub 0, which is your initial value, which was given to us to be 5. And then we're going to replace r with the percent, but we have to write it as a decimal, so this will be 0.17 t. And the only other thing we can do before we call this our answer is to add 1 and 0.17, so that would give us 1.17 t, and that would be our final answer for number 7. And so no, you don't have to do number 7 on your homework. We just did it as an example. Okay, let's look at number 10 now. A similar problem, but our numbers aren't quite as pretty. But we start with the same equation, p of t equals p sub 0 times 1 plus r to the t power. And our initial value again is 5. So we have p of t equals 5 times 1. But now we're decreasing by a percent. So remember, you put a subtract there for that, so that our growth factor will actually be a decay factor because it will be less than 1. And we convert our decimal, which is 0.59%, into a true decimal to eliminate the percent symbol. So we have 0.0059 to the t. And again, to go to your final answer format, you want to do that subtraction. And when you do that subtraction, you get 0.99. Let me make that first 9 a little prettier, if I can. 0.9941 to the t power. Now notice in this last one I didn't put a 0 in front of the decimal. Make sure that when you write these decimals, as we will be doing a good bit in this chapter, that you make your decimal point evident if you're not going to put the 0 in front of that. The 0 in front of that gives you a little bit of leeway as far as how obvious your decimal is. All right, now let's look at number 20, which says determine a formula for the exponential function whose values are given in this table. So the first thing you want to notice is that the directions just said exponential, so our g of x that we are tasked to find here will be in the form ab to the x. Well, we want to notice, very first thing is that the g of x output value at 0 is negative 5.8. So remember, that is your a. So we put negative 5.8 in place of a, and then we're going to figure out what our b is. Well, to do that, you pick another point from the table, and I like 1, negative 4.64. So the negative 4.64 is your g of x value, so we replace g of x with that, and then our x value is 1, so that just gives us b to the 1, which means to figure out what our base is, because b to the 1 is b, we're going to divide both sides by, try this one more time, we're going to divide both sides by negative 5.8, and that will give us b. And when you divide negative 4.64 by negative 5.8, you get a surprisingly attractive number of 0.8, nice and clean. So we're ready to write our final answer for g of x, because we know that our a was negative 5.8, our b is 0.8, and we stick the x exponent up there, and we're finished with number 20. We have one more for this video. We'll do number 22, and that will complete the exponential examples. And number 22 is a picture of a graph in your book, but the thing to notice is that they highlighted a pair of points, and since one of them is the y-intercept, we know that is our a. So this first point tells us that a is 3, and then we have a second point to work with in a similar fashion to what we just did on number 20. So we start with y equals ab to the x, the generic format for the exponential function, and we're going to replace y with 1.49, which is the y-coordinate from the second point. We're going to replace a with 3, and we're solving for b, so we leave b as it is, and then now our exponent is 4. Well, the first step to solving this equation so that we'll get our b and be able to write our equation is to divide both sides by 3. And when you do that, and this is a calculator problem, you wouldn't be expected to get these nasty decimals by hand. You get 4.496 repeating equals b to the 4th. Well, to get that 1/4 exponent off, we can raise that to the 1/4 power, and that will cancel. And we can do that as long as we do the same to the other side. And that's an easy way to get the answer with your calculator, by the way. So when you have that decimal on screen, you just raise it to the 1/4 power, and you will get that b is approximately 0.83491. So that gives us a final equation here of y is approximately, and you can use the approximate symbol even when you're writing an equation like this because of the fact that we had a lot of decimals going on in this problem that would affect our accuracy. So that saves you from swearing that it's equal by putting the equal sign. So we put our 3, let's try that again, our 3, thank you, for A, and then we'll round our base to 0.84. Decimal place a little better there. Stick an X on it, and we're done with this video.